covered a lot of ground so far. You know, what I like to see is that there seems to be a pretty general agreement. Thank you. That this Internet of Things in the industrial side is not something we need to wait for, but it's something that's here, and we need to figure out how to use it effectively. So do we have any questions?
Okay, thanks. So I really, I like all the positive thinking about focusing on the value creation, but in the back of my mind, my little voice says, if the good guys can get to my kit, my operating facility, so can the bad guys. So why isn't security part of this discussion?
I don't think we need to wait. Actually, security is a major part of the conversation, and for exactly that reason. Yeah, applying internet technology to anything means dealing with the fact that internet was designed for a world before security, basically. So actually, we have a major working group that applies some interesting security use cases to all of the test beds that we're developing at IIC, and we'll also be reviewing all of the test bed results to basically test them for secure access. It's a hard problem because, as I say, the network was, the internet technology, TCP/IP, was designed for a world in which security was, well, I wouldn't say not an issue. It wasn't thought of. I was there, so I remember. You know, and there was a book published in 1979 which listed all of the computers on the ARPANET, the sort of internet. I'm in there as one of the maintainers of the 200 computers on the network. I think there are 200 computers on the internet in my house at the moment. So things have changed. But security was not an issue then. Our security group is led by a gentleman named Sven Schrecker from Intel McAfee. And I won't say the problem is solved, but at least it's not something that's being ignored.
I think I would like to add the problem is definitely identified, and you may remember my slide when I said trust and security are basically a precondition for implementing that. And I'm coming from the history of factory automation, and it was exactly right. There was a time when our protocols were all proprietary. That means we had inherent protection, basically integrated protection. But now, as we are working in an open world and based on open standards, obviously now we have to take care of security. As I said earlier, no Internet of Things, no Industry 4.0 without security.
I have to respond to that, but we'll turn it into a real panel. But because the protocols were closed, we assumed that they were safe. Bullshit. I mean, and I know you agree, but I just wanted to bring it out. I mean, that's kind of like the assumption that no Siemens SCADA system could be attacked by a bug called Stuxnet. Simply because they were a closed protocol inside the SCADA system, or from the SCADA system to the controlled devices. So all of those systems can be hacked, and all of those systems could be hacked. By the way, I call bullshit on this all the time, because people will say, well, we're going to use internet technology, but in a closed network that's not connected to the internet. Again, bullshit. Every system that can be connected to the internet will be connected to the internet, and quite often by users who don't know they weren't supposed to. Anybody else want to?
Yeah, I just want to add that though there is no solution for the security, as other speakers mentioned, the very important topic that I believe is reasonably neglected right now is the whole insider problem. I think there is more danger will be coming in from your own personnel than from outsiders. And that may be just caused by just negligence, lack of training, other than malicious intent, or those, disgruntled employees that will be leaving your factories. I believe this would be the biggest problem, your own people, and we need to collectively think how we will be dealing with that in the new connected world.
I think we call that the Sony problem, right?
So the other thing I'd just like to mention is that we think this is a very important part of the whole Internet of Things story as well. But we've got a separate track where we're focusing on cybersecurity. It's been running all day. as well as a number of sessions devoted to it. So we haven't really featured it so much here in this session, although it's certainly important. Next question.
Yeah, Dominic John from OSIsoft. We've tracked to date, we're about just under 1 billion sensors, streams of sensors from our customer base today that we manage through the PI system. One of the things I look at the IT coming along, and you're going to have another source of information, these lick and stick sensors, data in the cloud. How do you see the sort of the customer's ecosystem going forward with the IoT and traditional data being captured?
I certainly will answer that, but did anybody else want to?
Why don't you start?
All right, I'll start. I always like to start and finish and be in the middle as well. The reality is nobody has a clue. That is exactly why we're building test beds. I look at all these efforts to build IoT standards, and as a guy who's been in the standards business for more than 25 years, since I was 5 years old, I say it's ridiculous. We don't know how these systems are going to be built. Even the manufacturers of the parts that go into these systems, like we've heard from, don't know how they're going to be used. So the right thing to do is to actually build something and test and find the disruptive products and services, and then figure out what standards are going to make those systems more interoperable. So the quick answer is we don't know. And the reality is, as we make the systems more interoperable, people are going to find different ways to connect systems. And they're going to be from the trivial to the absurd, and everything in between. I mean, I'll give you a very simple example. I woke up very early, I think like 3 in the morning, to pick up my sister-in-law from a JetBlue flight that was due in Boston at 4 in the morning, as most JetBlue flights are. Of course, it was delayed by 2 hours, but my alarm clock didn't know that and woke me up at 3 anyway. It should be trivial to connect my alarm clock to JetBlue's site and say, wake me up 2 hours before the flight arrives, or an hour before the flight arrives, rather than at some fixed time. And those are the kind of user customizations that we're going to discover by building it, and not by creating standards. Plus, given the fact that there are already plenty of standards, especially at the level of moving bits and bytes around, I think where we're going to end up requiring standards is in the semantic space, and that is going to require actually building test beds to see what things are going to be integrated.
Yeah, I think we have a lot of standards already in place. I think I remember that I personally was involved heavily with definition of OPC as a standard, which I think is very well suitable for many applications in the Industry 4.0 or Industry of Things business. So I think standards are defined by the marketplace and will be developed over time. So I'm not. We have to look into that, but I'm not worried too much. And the biggest issue is not syntax. The biggest issue is semantics, as you mentioned earlier. I agree 100%. And this is basically one of the preconditions to really automate the whole thing. So basically bring new stuff in, new devices in without basically parameterization, that basically an environment recognizes new devices. That is something we're looking for, and that's something we will have in future. But this needs some standards on semantics.
And I'll make one comment. So I think that customers are going to move at the pace they want to move. And I think as suppliers to these customers, the need to be able to interoperate and allow them to choose where they want their data. Do they want it in the cloud? Do they want it at each facility? Do they want it in PI? Do they want it some other format? As long as we're there to support them on this journey, assuming we address the security issues, I think that they're going to dictate to us what's going to happen.
And from a PTC ThingWorx perspective, as a software vendor, right now we're doing both, working with standard organizations such as IIC to have visibility into what the standard potentially will be and try to, of course, influence the standard also based on the work we're doing with customers. But we're also working with big customers that have initiative and that are themselves forcing their suppliers to work together, including the software vendors, but also their hardware vendors. And that's really one reason why we call it an IoT platform for now. We don't think that IoT today is ready for a set of out-of-the-box capabilities that everybody can pick and choose to based on exactly what they want to do. Reality is that today what we need is flexibility, because our business need as a company for each of us is slightly different, and different to a point where the flexibility and the ability to do different things is what is required, and then over time we'll see what transforms into standards.
And if I may add, on our side, we're just monitoring what's happening in the standards community. We believe that long before all arguments on standards will be settled, there will be software solutions that would allow to tune between different standards and implement that in the hardware. So the hardware solutions will have to address many standards through seamless software tuning up.
Okay, so we've got another question ready?
Yeah, this question is for Reinhold. You mentioned that you had your black box you installed that communicated to your call facility, and there's been a lot of talk in the group about real-time information and how the impact that can have an impact. So I guess my question is twofold. One, how real-time are you? Are you dealing in milliseconds or are you dealing in seconds? And two, how are you, because this is an implementation you have, how are you dealing with security?
I think it's a very good question. By the way, the black box is called blue box in our organization.
And by the way, you don't have to share with us the technology around it. Just want to make sure, how are you dealing from the security standpoint? Right?
Yeah, okay. No, I think the technology we are using is called blue box. And the idea is basically that we have our own secure link to the cloud, which is basically between the cloud and the blue box, and this is something we really can make secure. And then we connect our blue box to the controller of the elevator, for example, and this is a proprietary connection, whatever the elevator is looking like. This is the way how we handle security. So we have our secure gateway between our blue box and the cloud, and on the other hand, when we are talking about real time, in this case, we are talking about service data. That means service data are basically real time if they are delayed by 1 second or even more. Normally it goes faster, it works faster, but I think it's not necessary because we're talking about service. It's totally different when you talk about machine tool or when you talk about running the elevator, that's a different animal. But when we talk about service data, 1 second or so is by far enough.
If what you're doing is sending a service person to service the machine, if it takes 2 seconds instead of 5 seconds instead of 2 seconds to get it there, it's probably not much difference in outcome. I will say, as a one-time real-time systems developer, I really hate the misuse of the word real-time because it doesn't mean real-time, he means fast. And those are different things. When I was talking about real-time, I meant real-time, like we got to get the information to the maintenance base before the plane takes off. There is a deadline. There's a hard deadline. The plane backs away from the gate, turns around, takes off. I have a speech that I give to classes about the difference between high performance and real-time, and it's mostly about the Iridium satellite system. So I know a lot about Iridium because it uses many OMG standards. Iridium is a satellite-based telephony system. There are 66 satellites in low Earth orbit, 400 kilometers up. It's basically a cellular system where the cell towers move too, not just the phones. Satellites are in polar orbits, which means that every 45 minutes, each satellite crosses one of the poles, north or south. And as the head of software for the project told me, there's something called the Pauli exclusion principle for Iridium, which is if 2 satellites are in the same place at the same time, I get fired. You know that's going to happen on average 22.5 minutes before it's going to happen. So you don't need a particularly high performance system. You've got 22 minutes to upload the command and have the satellites avoid each other, but there's a deadline. That's a real-time system. So I think most people, when they say real-time, they mean high performance. But there are some real-time systems that have real deadlines, like the plane is backing away from the gate, and we need to know that the left engine is going to fail an hour from now.
Okay, we have another question teed up in the back. Yep.
Thank you all for the presentations. It's comforting to see that you converged on the topics that you talked about, on the history, the benefits, and what's being done today as far as scenarios. My question is more about the challenges and whether you agree on what the challenges are. We heard some security concerns being raised, possibly social privacy concerns or interoperability as we talked. I wonder if you have the same, if you're on the same page on regards on which one is the most challenge, what is being done in that regards? And to tie it to the introduction, when you talked about internet hasn't changed all the businesses yet, so why? And what was the challenge and what is being done?
Well, that's because it takes time, right? And interoperability and security are the technical challenges, but I'd like to actually mention a social challenge that none of us have mentioned, and that is, in a world of driverless cars, the function of a taxi driver is to find another job. And there are hugely socially disruptive trends that have come out of Internet of Things that are not very well thought through. I actually think those are going to be the greatest challenges, and we're going to see another wave of what in the 19th century were called Luddites, people that didn't want the Industrial Revolution to change the world. That, I think, is actually the biggest challenge, much bigger than the technical challenges. I think the technical challenges, number one, can be overcome, and number two, we're going to build the systems even if we don't overcome the technical challenges. For example, security is a great example. Everyone says we shouldn't do it unless we can get 100% security. Okay, fine. Nice statement. Never going to happen. We're going to build these systems.
And I think with Internet of Things, the same will happen as happened with the other three industrial revolutions I mentioned earlier. Some jobs were going away, or a number of jobs were going away, but new jobs were created. And I think the problem is not that we have to get rid of the people. The problem is how can we take the people with us? And that's, from my point of view, the biggest challenge. And I mentioned that in my presentation. We have to train the people. This is a culture change. People have to accept the change, and we have to train the people. So we have to take the people with us. We don't have new people. We have to take the people we have with us. That's basically, specifically in good old Europe, the biggest issue, that we have to take the people and bring it into the new world.
And one challenge I would probably mention, we think there's an agreement in the industry that industrial internet or Internet of Things is here. Companies have already started to leverage it. One big challenge as a manufacturing company is, where do I start? Just simply, there's one challenge today is that there are so many things we can do. One fundamental question you have to ask yourself is, where does it make sense for my own company to apply IoT? What is my company valuing? Are we into speed? Are we into low cost? Are we into customer service? Are we into complex equipment that requires a lot of service? Do we want to move from selling products to selling service? Do we want to win in the marketplace through operational efficiency versus selling more and more products to broader market? There's so many things we can do, or you can do. We think that one of the main challenges is just to decide where to start. And we don't need to boil the ocean from the start. There's a lot of things that still need to be figured out for IoT, but reality is that if we have a very specific use cases and your company understands exactly the value that you're going to get from that use case can be enabled pretty quickly.
Well, that's a very interesting comment, and I don't disagree with it at all, but it strikes me that we are going to boil the ocean, but just little bit by little bit, and everybody's going to start in a different place. So it's a very interesting time.
Yeah. I agree. The industry will boil the ocean, but as a manufacturer, we will all start somewhere, and that's really one of the big challenges.
Yeah.
So one other issue that I think is secondary to the security issue and the social issues and economic issues, there's this element of who owns the information. So we talked about farmers and the use of their tractors and fuel usage. Whose information is that? And I think there's going to be a lot of information about power usage, where power is on the grid, how equipment is being used, how airplanes are being used, and so on. And there will be fights over the data. And my view is, let's free the data. More information will help us innovate faster.
Which is fine. I want all your information. I think that's a great idea. I think that's a great idea. You should share all of your internal data with me.
Let's talk.
Okay, we have a question in the back.
Yeah, thank you for the presentations. I had two questions. How does the Internet of Things affect traditional automation players who, I think it's the bread and butter business of doing this? So how will this be impacted, and what do you see as competitive threats coming? And second, I think different parts of the globe has labor issues which are very different, and I come from Asia and we have billions of people there, so the man-machine interfaces are different across the geographies. So how do you see Internet of Things unifying something when we have very different social structures, educational levels being different needed for IoT? What are the bearings from these two sides which might impact the industry?
I'll take a shot at the first one, impact on automation companies, by just misquoting probably the CEO of General Electric. I never get the quote exactly right, but he basically said if you went to bed last night as a manufacturing company, you woke up this morning as a software company. You better prepare for. In other words, you better prepare for that change. And automation companies that ignore that won't have to worry about being in business anymore. I don't know how long it's going to take. It's certainly not overnight, regardless of what Jeff said. But this change is already happening. And you look at manufacturers. GE is the canonical example because they get a lot of press. But they've realized that software is central to everything they do, and that's changed the way that they manufacture systems. It's also interesting that they took their first major software product, Predix, which predicts the failure of General Electric devices based on benchmark data, and a few weeks ago open sourced it. So that's kind of an interesting software model for a company that thinks that manufacturers become software companies.
I think the manufacturing or the automation companies have to change and to lead the effort. Otherwise, they go away. That is, from my point of view, that's simple. But I disagree with that manufacturing companies will become software companies. I think ThyssenKrupp is pretty much in building systems and hardware. We do have some software solutions like electrical steering, but I think we will be a very smart manufacturing company in the future. So I think, and my statement is always, what's called the old economy will be the new economy, because we really generating value, touchable value, and this is something which will be more and more important in the future. We do it in a better and a smarter way. And as you said earlier, I think we really have to take the people with us. That's the important part. And what's, by the way, funny, when we are in the discussion in the platform efforts for Industry 4.0, there are two groups of people which have a hard time to talk to each other, even both talk the same language, because they use different words and coming from a different world. They're the manufacturing people and the IT people, and it's extremely hard to bridge that gap between thinking like a manufacturing person and the other person on the other side of the table thinking like an IT person. And so we do a lot of translation and all those things. That is, by the way, one of the biggest issues we see, that we have to bridge the gap between manufacturing and IT.
Yeah, it's the same for us as a manufacturing company. We don't really see ourselves moving into services company, but digital transformation is very important for us, and this would be our first step into the industrial internet with our factories. And it boils down to a very simple fact: you want to get rid of paper as your first step in your digital transformation, and your next step is to make your IT people to talk to your operations people. I think in a very near future, across all the manufacturing companies, we will see a big transformation when you will have the IT wing of the company talk more and more with the operations wing of the company, because this is the only step towards success, towards industrialization, digitizing of industrial environments and Factory 4.0.
And from a PTC perspective, the impact on competition has been significant. If I take just us as an example, we built an IoT marketplace that is basically a way to have partners certified and working with the platform. But for PTC, being an enterprise software company, for the last 24 years, we've been partnering with software companies. And today with IoT, what we are doing and what we have to do is to actually partner with hardware companies. So today working with the Rockwells and all the other automation vendors, and working with T-Connectivity and National Instrument and all these companies that have devices that will be on the products, on the equipment, on the asset that will pull data from. For us as an enterprise software, it fundamentally changes the partner ecosystem.
Okay, so now we're going to move on to the last session of our workshop today. But first, join me in thanking the panel and the speakers.